Welcome to Quality with Mubari. This is Mubari here speaking, and today we're gonna cover the standard deviation. And today we're gonna explain what is the standard deviation, right? So, standard deviation, in simple terms, it's a statistical measure that we use to indicate how much a set of data varies from the mean, right? So, you got a data set, and you're trying to figure out whether your data is dispersed enough or you have a wide range of values, right? And you're comparing this to the mean that you have, to the average, right? So, in other words, a low standard deviation means that the data points that you have are clustered together around the mean. On the other hand, if you have a high standard deviation in your data set, this means that the data points that you have, they are spread out over a wider range, right? And you might have some outliers. So let me show you a visual representation of what we just mentioned. So the curve on top is showing here the high standard deviation, right? A high standard deviation, you can see the mu sign here. This is the average, and the sigma sign. This means this is the symbol for the standard deviation, right? So the high standard deviation, you can see that we can have here lots of data points all over this bell shape, right? We might have here, let's say, a 10. We can go and you have 40. We can have 59, and then we can have 90 something. So this means that we have data points all over the curve, right? On the other hand, we have the low standard deviation, which is the one down below here, which is, you can see the mu, you can see the sigma sign. This means that the data is clustered or it's close together around the mean, right? So the probability of having outliers in this case is not as much as the curve above, because you can see here that the data are just being so close together, and the data sets or the data points that we have are not that dispersed all over the place, right? So that's I hope this visual representation explains the difference between a high standard deviation and a low standard deviation, right? And then moving on here, we can see the formula that we use for the sample and the population. So in case you're calculating the standard deviation for a sample, we use an uppercase S, right? This is the symbol for the standard deviation when we're talking about a sample. The equation is you take the the xi here, which is the each value from the sample that you have, right? So you take each and every value, and then you subtract that from the mean, which is here. Since we're talking about a sample, we're talking about x bar, right? Which is the x and the little dash above the x. That's called x bar. And then once you're done with the subtraction, you square that, right? And then you take each and every data point and do the same calculation for it, and then you add them up, which is this symbol means, which is you sum, like each and every data point is summed, right? And then you divide that by the degrees of freedom, which is n minus 1. N here, lowercase n, is used with the sample. However, when we're talking about the population, we're talking about an uppercase n, right? I'll explain the population right after this formula. So n minus 1, and here is resembling the count for the data points that you have in a data set. So if you take a sample of 30 data points or 30 values, then we have 30 minus 1, right? So that's how you calculate a sample. Same goes for the population, but we're gonna change some symbols. Instead of an uppercase S, we're gonna use the sigma sign, right? You're gonna see the sigma sign a lot throughout your QA journey, so you know, get used to this symbol here. This is the standard deviation, and then the equation, it's pretty much the same. However, instead of using x bar, we're gonna use the mu, which is the mean, right? And you divide that by an uppercase n, which is the number of the values in your population, right? We're gonna cover an example in this video here using this formula, because we're talking about a population in the example later on. All right, and this is the formula in details, just like we mentioned. The sigma sign is the population standard deviation. The n, the uppercase n, is the size of the population that we have. Xi here is each value from the population that we're dealing with, and mu is the population mean. All right, so let's circle back to the key points or the main usage of the standard deviation, right? So why do we use it? it's simply a measure of dispersion. You're trying to figure out whether your data points how far they deviate from the average, right? So we're trying to quantify how much data points deviate from your mean. So that's the main purpose for the standard deviation. And then the second bullet point here says that the smaller is more consistent. What this means is that when you have a smaller standard deviation, this simply resembles that your data is not as dispersed as another dataset that has a large standard deviation, right? Or a huge standard deviation. In simple terms, a smaller standard deviation means that the points are more consistent or more clustered around the mean, right? So that's regarding the second point. And then for the fields that the standard deviation is used in, we have lots of fields, mainly statistics and QA. And then moving on to this example here. So this is a quick example just to show you how we can use the standard deviation. So let's say we have two groups of students taking a test, and both of the groups had the same average score, right? So let's say that we have group A, group B, and both of them had the same mean. However, one group had a higher standard deviation, right? Which means that the scores are spread. Let's say some of them scored 100, which is they scored 100 out of 100 in a test, which is amazing. And some of them didn't really do well, and let's say they got 42 or 43 in a test, right? So this means that the standard deviation here is higher than the other group, because the other group, they have low standard deviation where they show more consistency in their scores, and the scores are not as dispersed or not as spread as the other. Let's circle back to this curve here where you can see this is a good example if we compare, let's say, group A and group B, right? So group A, the values in this group are dispersed, or they are, you can say that they are far away from the mean, right? However, the other group, they had a low standard deviation where the values are clustered around the mean and the scores are somehow consistent. And let's take another example here. This one here is showing some numbers and how you can actually calculate a standard deviation, whether you're using Excel, whether you're using Minitab, or you can simply draw this table out and you can calculate the mean as we're speaking. So we're talking about the population here, because you can see the mean here is being resembled with mu, right? And the n, which is the count of values that you have in a data set, is resembled by an uppercase N. Those symbols, they simply mean that we're talking about the population, right? So let's say you're trying to figure out the height for each student, and you're trying to figure out the standard deviation for this study that you're doing, right? You take the height in inches for each and every student that you have in your class, and that's the population, right? So you got a student whose height is 56, 65, 74, 75, 76, right? And then once you're done with getting or collecting the height, you got the mean for that. So simply you add all those numbers and you divide by the number of values that you have, which adds up to 75, right? So that's the mean that we have. And then the third step, you subtract the mean from each and every data point that you have, which is x minus mu, which is first step 56 minus the 75, 65 minus 75, 74 minus 75, and so on. And you do that for each and every data point that you have, right? After that, you got the result, which is negative 19, negative 10, negative 1, 0, 1, and so on. And then you square this value, so negative 19 squared is 361, negative 10 squared is 100, negative 1 squared is a 1, and so on. And then once you get this number, you simply add those numbers up, so you get the sum for that, 784, that's the sum. And after you get the 784, you divide that by the number of values that we have, which is the uppercase N. And in this dataset here, we have 9 data points. So 784 minus 9, which is 87.1. And then after you're done with that, you simply square root the 87.1, giving you a 9.3. So that's regarding the calculation for the standard deviation, how you can use it. And I hope you like this video. Let me know if you need if you have any questions, any concerns, you need any help with any calculations, let me know. And yeah, as usual, thank you so much for watching and stay safe.